live stream. So let's see if it's working. One time I spent an hour and then discovered it wasn't working. So my poor bird is dying. That's Percival. I don't know if you can hear him. He was coughing up blood. That started a month ago, so he hasn't died yet. I don't. He was coughing up blood. That started a month ago, so he hasn't died yet. He's like 16 years old or something. I don't know. They live to well, somebody had one live to 30. We could. Percival. They lived to I think the world record. I don't know what he is. He's crippled and stuff. My sister raised the cockatiels 1996, maybe. I don't know. Anyway, so that's a downer, my dying Percival. So what are we going to talk about today? So I did a release. If you're watching this, you probably paid attention. So I thought about doing a video to try and get to the top of Reddit. I used to get to the top of Reddit pretty frequently. Somehow I think my internet is not the real internet. I have pretty good reason. My internet seems too small. Like, it runs out of stories and stuff. Anyway, so if I wanted to get to the top of Reddit, what would I talk about? My kernel is a good topic to talk about. The core of a kernel is the scheduler. This is my scheduler. It's a round-robin scheduler, which just means it goes around in a circle and gives each task a chance to run. As a matter of fact, most people, quote unquote, remove a task from the queue. It's only an implementational detail, but I have a let's see, where is it? I have a bit that tells it that it's suspended, and when it goes around in a circle, if that bit is set, so when it's looking at a task to see if it should swap it in, it checks if it's supposed to get killed, and it checks if it's awaiting a message or if it's suspended. Oh my Horsey, my dog. Here's my dog. His name is Casino. Kind of a weird name. My parents' dog, I guess. Anyway, so I don't remove them from the queue. I just check if the flag is set and then skip them. And there's one more thing I check, and that's if it's time to wake up. So, oops. So for a normal task that's at the command line, it's waiting for a message. If we want, we can look at the wallpaper, and the flags will let us know. We can see those flags on the wallpaper. That's what I'm trying to say. See where it says flags? There's two sets of flags, CPU flags and or task flags, and the other flags are display flags. So let's try and find. So this task is number. Whoa. Okay. This task is 3F D6 D7. 3F D7 6228. So these two, you see these two lines where it says get key. Let's look at the flags. They're flickering, but one flag is that's bit 8 and bit 3. Looks like bit 8 and bit 3 are flickering. So let's look at the flags. Task flag. Bit 3 is idle, and bit 8 is awaiting message. So I'm looking down here. So that's why it's been swapped out. So what the scheduler is doing is it's looping through all the tasks on core 0 and checking if they have a suspend, a waiting message, or is checking if they're not ready to wake up. So this is a report of all the tasks on CPU 0. So it goes around in a circle. And it swaps those tasks in. Anyway, so what do you want to do? Let's look at the scheduler. Some people push the registers on the stack when they do a task switch. Over at OS Dev, these guys are, they delusionally annoy me all day. osdev.org, this is the forum. Anyway, so they have a tutorial to get you going with operating systems. Well, anyway, they present it like it's the only way to do it. Oh, shit. Be right back. I'm going to turn this off and get the phone. I'm back. Anyway, they teach a technique where you push onto the stack. So if you want to know how I do it, here's where I push my registers, but it's not the stack. It's I redirect the stack pointer to point at. This is my task record, and in my task record I have a spot for the registers. Here's the spot for the registers. So they push it onto a stack and then pop them off. This is really weird. It would be more normal to do move but this is faster. So I redirect the stack. I don't know if I'm explaining. Anyway, oh well. Let's talk about physics. Yes. Oh, let me go ahead and finish talking about this. So the main tricks, you have to save the context and you have to restore the context. So you save the 16 registers that are in 64-bit mode, and then you also save the, we're restoring right here. Just for purposes of bookkeeping, we record how many minutes have been spent on this task. If you'll notice on the wallpaper, there's a cumulative CPU time. I could get rid of that. It's kind of, I don't use it for anything. I don't think I do. Not to mention, a good reason to get rid of it is I'm reading the timestamp count, which is the CPU gigahertz clock. So this is, hey, why don't we do that? Why don't we get rid of this as an exercise? Because you might ask, why would I want to do that? Well, it's faster, and mine is supposed to be minimal, kind of. This is garbage. It's really easy to add garbage features, so I'm going to get rid of this. It's going to, if you think for 1,000 years, do you know how much electricity this will save? It's garbage because the CPU clock, the time varies. So these are not even these are not uniform minutes. It's based on they increase and decrease the CPU clock. Anyway, so the other thing I was going to say is we saved the registers, and we also saved the floating point, the entire floating point bank of registers, the state. We saved the entire state of the floating point into the task record. It's a 512 byte block of code. Okay, let's get rid of this. Let's just double check timestamp. Let's look for total time as so I say find total time. This is garbage. It's on the wallpaper. I have to get rid of that. So let's just do it. Sometimes you gotta just do it. Time. I really don't think I use it for anything. If I crash everything, then we'll know better. Okay. So let's start over. Let's get rid of. Let's do these one at a time. So total time. Swap counter. Okay. Scheduler. UR history. Do I use this anywhere? No, I don't. I immediately destroy the value. So let's just quit being dramatic. Miscellaneous. Okay. Task total time. There's a chance that I use it, but I really don't think I use it. I might use it in the idle count. I hope not. Task total time. Okay, so I got rid of find if it's in. So I set a limit of 100,000 lines of code. It's kind of hilarious that I am getting rid of this. Oops. There's a help file for CPU. Okay, so I don't want to get rid of my help file, do I? Maybe I do. If I hit F1, CPU cycles, time, CPU cycles. Okay, let's go to busy wait. Okay, so we get rid of that. Let's go find a busy wait. Control F, busy wait. Okay, so I have to link oh. Okay. What I'm talking about is, what I'm worried about is the help file. Where are we? How about get timestamp count? Let's go by that. I'm trying to find a place. There it is. Okay. I'm trying to save lines of code, and I just I'm just doing some accounting, busy work, dealing with okay, we still need the calibration wallpaper. Okay, so we have to remove it from the wallpaper. Sometimes this makes me a little bit sad. When you throw away work that you've already done, this is not really much work. But it makes me feel joyful because it reduces the lines of code. We really are trying to be somewhat minimal. So, hey, do you think it'll fit? Maybe. It fits. Woo! We're going to reduce a lot of lines of code. That's the best feeling in the world, reducing lines of code. Now, actually, it makes you depressed when you remove features. So what is this? Task rep. Oh, this is task rep. That's what we just ran. So we have to test. We really should test task rep. Okay, so it doesn't look like it has a header. When you're working, the F command is really good. And then work from the bottom to the top. Otherwise, the file line number for the link will be inaccurate. Oh, we have a lot of these. What the hell is this? Now I'm getting nervous that we might have to undo. Oh no. Okay, good. Good. This is not the same total time. I'm double checking. I'm going really slowly. Okay, so total time. What's the other one we want to get rid of? Time slice start. Okay, so I'm going to compile. Shit. compile, reboot. Okay, so it didn't die. Piece of cake. So find time slice start. Okay. So swap counter. Time slice start. Should we move this integer to be with other integers? No. Okay. Time slice start. Restore context. Okay, so you know what I should do? Okay, so this is history. Boy, we're really saving a lot of code. I just hope we don't hit a problem. Okay, so we didn't really need that after all. So just to feel good about ourselves, let's boot the old version on the D drive. Now what I'm going to do is I'm going to kill this task. Then I'm going to say while true yield. So look at the CPU. This is how long it takes to swap out and swap in. With any luck, we should, okay, so it looks like it's about 4,500. 4,500. With any luck, we just increase the performance of our, okay, no, 4,400, 4,500. So get rid of this. While true yield. 4,500, 4,600. It's worth it. Isn't that cool? We just improved the performance pretty radically. So now let's see what we did to the line count. 899. I bet we're down to 89. I bet we're down to 850. No, how many did we save? We probably saved 30, 20, 30. 899. So we're going to got rid of time slice start. Let's just see. I don't normally waste my breath. Oh well. Okay, so yay. So I had big plans when I first started this operating system. That seemed like it was a good feature up until the CPU started changing frequency. When I started in 2004, the CPU stayed at a fixed clock, so I could use the HPET if I wanted to. High performance event timer, HPET. So this is an accurate. It's not quite fast enough. High performance event timer. It's about. Well, we can see how many. Okay, let's do I64. I equals high performance event timer sleep 1000 time colon percent D backslash N H bit minus I. So it looks, it's 14 megahertz. That's actually not fast enough to record our, oh, I guess it is. I was wondering about, we can swap in and out 4 million times a second. So that's actually not fast enough to do the accounting for, oh well. Anyway, so I'm going to upload to my website. You think we should do a test suite? Nah. What about, let's do task rep. Beautiful. You think we should display more information on task rep? Like, what else is there? We have the flags. Oh, let's look at the wallpaper. Now we have room on the wallpaper for something else. What's that 0? Huh? Oh, that's the, that's the stack trace. The yellow 0 is the stack trace. So we have room. We could, whoa, we have a lot of room. In fact, why do we have so much room? It's not that. Why wasn't I using it before? So, how can we improve the wallpaper? We could give more room to the description. We could. That's valuable real estate. We just made some valuable real estate. Why don't you guys post? What do you think we should put? We could just look at the task record and find out. Okay, so we'll let that. That's going to rebuild my website. Now I'm going to look at you guys to see who's here. Find out. Okay, so we'll let that. That's going to rebuild my website. Now I'm going to look at you guys to see who's here. Find out. Okay, so hello. We'll let that. That's going to rebuild my website. Now I'm going to look at you guys to see who's here. Find out. Okay, so we're rebuilding after removing the task bookkeeping. Let's get God to talk. So let's go to Reddit. Oh, well. Oh, we have to wait until it's done rebuilding. Well, we could go to a random number. Okay, let's get God to talk. We go to, did you know NIST is offline? Look at this. 7/26, that's yesterday. It stopped posting. So, let's go to, oh, let's do hot bits. Okay, here's what we're going to do. We're going to extract the first 5 decimal digits. These are Geiger counter random numbers. We're going to take the first 5 decimal digits. Get hot bits. So now we go to okay, so 87500. 87500. Whence art thou? That's whence is what, when. So this is a joke about the time. Whence art thou? But Jesus gave him no answer. Then saith Pilate unto him, okay, so that was cool. Let's see if it's almost done. Okay, what else do you guys want to do? Okay, what else do you guys want to do? Maybe you can put the symbols in a new column instead of a new line. The wallpaper. Yeah, I want the tasks to pop out. They run together. Like I need a way to indent or something to make the wallpaper more readable. The chat pops out. Okay, so that looks good. Now this is how I upload to my website. So I added a bunch of, well, anyway. So the wallpaper, get rid of the zero. Somebody suggested getting rid of the zero. I guess if it confused me, it would confuse other people. I could do that. It's lines of code. I don't really... There's no sense being... Oh, that's what we were going to look at. It was 899 when we started. Now we're down to 873. So we saved some lines of code. I don't want to be silly about saving lines of code. What I mean is you shouldn't be too worried about wasting lines of code. Anyway, so how could we get this to pop out? You think indenting would... We could put a star at the beginning of the line. Star, star. How about a... I know what we could do. Okay, it's valuable real estate. Eventually we want to reclaim the real estate for something. Why don't we look at the task records, see what's good to display. Okay, I can tell you what everything is. Okay, the task signature, that's a 4-digit. As a matter of fact, on this task, every task record has TSK signature S. That's just to identify, to tell if it's a valid task. When inhibit, these are some flags for those are flags. We could display those. Those are we could make a hexadecimal number. I think they're about. Let's look for when inhibit. win. So that's an awful lot. A lot of digits. Anyway, so we can display the win. What was that? 2 semicolons. Okay, no, I just saved it. Okay, so let's make sure I didn't ruin anything. Okay. So I had 2 semicolons that I just got rid of. Let's see if that happened anywhere else. Control F, semicolon, semicolon. Okay, no. So Control F, C task. So we could put the win inhibit flags on the task record. The wake jiffy. That's an entertaining value that would make the wallpaper look entertaining. It's too many digits though. We could display the low digits. No, anyway. Task flag, display flags. What do we have? The window coordinates. No, we don't want those. So I could add more digits of the description, but exception stack answer random number seed. So win inhibit is the only thing that looks good. This would help you debug if you're writing an application, and so it looks like okay, let's go. How much room do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have about 13 digits available. That the win inhibit would, oh, what do we need? 8? No, we need 16, and that's 13. We need about, okay, I'm gonna do it. That's, so first of all, you'll see. I'm going to put one digit, two. I'm going to put 2 digits as a line. Okay, this goes in reverse order, bottom to top, in case you're curious. So the stack is up above. So I'm going to reboot, and you'll see what I did. Okay, so now, what if we do dashes? Stars, what do you want? Dashes? Kind of looks, I think the word would be African. That's my definition of African. Like African engineering. I don't know if that really helps. I think I'm going to get rid of it. Okay, so instead, I'm going to put win inhibit task, win inhibit, and we will say 8 X. And over here, darn, we add lines of code. So 1, 2, 3, 4. 1, 2, 3, 4. So how can we have 5? Because we have a colon. Oh, there's no colon. Okay, didn't I say 8? Yeah, there's 8. So when inhibit, how many digits total are there? There are 1, 2, 3, 4, 5, 6, 7. There's 7. I guess we'll leave it as 8. Was that, as a matter of fact, was that a, I think it was 64 bits. No, it's a 32-bit. Okay. So it's, so everything is working well. We just need, hold on. Why don't we call this